So hello children, now we go to the part 5 of our lesson on Pythagoras theorem. So part 1 I have given you the concept of Pythagoras theorem and Pythagorean triplets or triples. Then part 2 and 3 I did numerical value based question where values are given. See, part 4 I have done proving questions where no values are given. So this is my third and final video lesson on numerical value based question. We simply cannot call it value based question because the word value based is a little different meaning if you don't put the word numerical value. So here's something very important before I do this 4-5 sum based on values where the values are given. See, if two sides are equal, remember because basically I'm talking about isosceles right angle triangle, children. What I'm talking about isosceles right angled triangle. So if these two are equal, I'll show you the hypotenuse in this situation is root 2x. This is very important for class 9, 10, 11, 12 and all. Maybe in physics also, not maybe in physics also. Okay, in trigonometry also, mensuration also. And we are doing geometry, remember. Now, by Pythagoras theorem, PT is short form of Pythagoras theorem, right? We know x square plus x square, square and this plus square and this is equal to. So this is what I have to prove, children, remember. Okay, required to prove. So first let it be h. Let this hypotenuse be h. So this square plus this square is this square. So I'll show that h is equal to root 2x. So here if you see, children, we get 2x square is h square. That means h square, hypotenuse square is 2x square. So h is root 2x square. So x square, when it comes out, root 2 remains, x square becomes x. So hypotenuse here is root 2 times one of the sides. So this, if two sides are equal. So very important result, children, this is. If two sides are equal, like here, see. So what is question number 13 if you see? Okay, here I'll apply this knowledge. Okay, so remember, if two sides are x, this is root 2x. Provided this is a right angle triangle, that means this is an isosceles right angle triangle. Next, here the diagonal is given, we have to find area and perimeter. So just I taught you, let the side be A. What you can do, let the side be A. So here I'll have enough space. Let the side of square be A. Okay, so what happens here? Diagonal D is root 2a, which is given equal to 10. So what is my side? 10 by root 2. Okay, diagonal, okay, is root 2a. This is root 2 times a. So root 2a is 10. Okay, so this is the side. So what is area of a square, children? Area is a square. You can do by traditional method also. A square plus a square is 10 square. You can get like that also. A you will get 10 by root 2. What you will do? A square plus a square is 10 square. 2a square is 10 square 100. So like that you will get. Okay, if you wish I can show you over here. Method 2 if you want to find the diagonal. Okay, a in terms of diagonal. So what happens here? A square plus a square is diagonal square, 10 square. So 2a square is 100. A square, children, is you will get 100 by 2 is 50. Okay, so see here, a square area is you square it. So what do we get, children? 100 by 2, 50 centimeter square. See, by this method, there are two methods, same thing you will get. One method you will get, children, is root over 50, which is 5 into 5 into 2. This will be 5 root 2. Or otherwise you see root over 100 is 10 and root 2. So same thing you get, children. 10 by root 2, and these are actually equal if you see. Okay. So here also you'll get same thing. 5 root 2 also if you apply you will get same answer. Or see, root over 100 is 10 and 2 root over is root 2. Okay, so both method. And the last thing is perimeter, children. Perimeter is 4 times a. So 4 times a and 4. What is a? 10 by root 2. Okay, so here see this method and this method also I'll show you. So this is, we rationalize it, we have done rationalizing because denominator you cannot leave it root 2. So what we get, 40 by 2 root 2, and this will cancel. So finally we get 20 root 2 centimeter. Okay, so finally we get, okay, 20 root 2. So here if you see I'm writing up this 240 by 2 root 2. So this is 20 root 2 children. So this way also if you do, you will get same answer, 4 into 5, 20 root 2. So this method also will give you the same answer. Kindly pause the video and copy. So see question number 15. So this is a very simple application of, if you have seen my, please see my part 1 of the video, Pythagorean triplet. This is 12, 13, this will be 5. We have seen, I'm saying you don't have to do like this, but how fast you can get answer. 10, 6, this is 8. Okay, so these two both are Pythagorean triplet, if you remember, 5, 12, 13, and this is actually multiple, 3, 4, 5. So this is 3 2s are 6, 5 2s are 10, this will be 4 2s are 8. But this will give you answer 5 plus 8 is 13, but just I'll tell you in short how you will write in exam. So in exam we have two triangles, children, if you see. So let us do fast. In triangle ABC, here we have to get BC. So you know AB square plus BC square is equal to AC square. So here 12 square plus BC square is 13 square. BC square is 13 square minus 12 square, 169 minus 144. Okay, so you get root over BC is 25 is 5 centimeter. We get BC, children. So here I am doing for another triangle. So this is part 1. Then in triangle CDE, this triangle, so same way you will get, children, CD square. Here I am doing directly this square, any other side is hypotenuse square minus one side square. So 10 square minus 6 square, this is 100 minus 36. You can use idea of expansion also. CD is root over 64 is 8 centimeter. So this is 8 centimeter, this is 5 centimeter. So finally what we get, children, BD. So this is what you will write is BC plus CD. BD is BC plus CD. So BC I got 5 plus 8. So we get, children, 13 centimeter is the answer. So if you know Pythagorean triplets, directly mentally you can do, but you have to show the working like this. So this is part 1, part 2 here, and this is the last part, children. Okay, so this is my part 1. Then come to part 2, and this is the third and concluding line you will have. So kindly pause the video and copy. So children, now we go to question number 17. If you see number 17, it says that in triangle ABC, AB and AC is X, BC is 10, and the area of triangle is given 60 centimeter square. Find X. So before you prove, see, I told you I have proved an equilateral and isosceles triangle. One example I showed you that these two triangles, if you drop a perpendicular, they are congruent by RHS rule. Right angle triangle, because we are dropping a perpendicular, hypotenuse is equal and one side. So since these two triangles are congruent, you can do that in detail. I have shown you in the previous sum. Okay, so see that these two will be equal then. So finally what happens, children, we get this two triangle congruent, these two are equal. So we have BD is equal to DC, CPCTC. Okay, because they are congruent. Now it's very easy, see, children. We have to find the side of the isosceles triangle. So we know, see here, x square plus 5 square is, let this height of the triangle be small h. Let the height of the triangle, let the height of triangle be small h. Okay, because capital H I have used for hypotenuse. So h square. So what do we get, children? X. Okay, h. h is x square, no, this is bigger, x square is equal to 5 square plus h square. Okay, so h square is x square minus 5 square, and if you see h is x square minus 5 square root over that. Once more, this square plus this square, children, is this square. So x square is this square plus this square. This triangle also you can take same thing, they are congruent triangles. So h square, bring 5 here, you get this. So height is this. So remember, height of this triangle, most important thing for solving this is this. So now final step we see. So final step, what we have, children? Half base into height. Half, this is area of triangle, half base into height. Height is root x square minus 5 square is 60. Okay, this is half base into height. So first, by using Pythagoras theorem, we have got the height in terms of side. Okay, height in terms of side of the isosceles triangle. So this will cancel 5, 5 will go there. So we have root over x square minus 5 square is 60 by 5, 12. So squaring both the side. Squaring both the side will get rid of the root sign, children. So what we get, x square is 12 square 144 plus 25. So 169. Therefore x side is root over 169 is equal to 13 centimeter. Okay. So this is what is question 17. You can pause the video and copy, or later on we go to question number 18 over here. See, 18, two diagonals of a rhombus is given. Rhombus, all sides are equal, children. So diagonals are 30 and 40 centimeter respectively. So some properties you have to remember over here. Diagonals of a rhombus bisect each other. Means if this is 15, 30, this diagonal will bisect it into 2, and this diagonal will bisect into 2. So finally you can call it O also. So finally, if you see one triangle, you take, children, in triangle AOD, this triangle. So again, if you use Pythagoras triplet, I'll tell you, children, this is 3, 4, 5 that you will see. This is a multiple of 3, 4, 5. So I have taught you in first video 3, 4, 5. So this side is 5 times, this side is 5 times, the last side is 5 times. So we will get this as 25. See how we get? By Pythagoras theorem, 20 square plus 15 square is equal to AD square. AD is one side, children. All sides are equal. Okay, so AD square is 400 plus 225. AD is root over 625, which is 25 centimeter. Okay, so if this is 15, this is 20, this is 25. So if you remember, multiple of Pythagoras triplet is also a triplet. So here I told you this is 15, this is 20, this will be 25. Ultimately the base triplet is 3, 4, 5. 3 5s are, okay, 4 5s are, 5 5s are. So think about it. In the beginning it may look difficult, but this will be of immense help to you in future. So finally, what is perimeter, children? Perimeter is 4 times your side. 4 into side we have. So 4 into side is 100 centimeter we will get. Okay, children, kindly pause the video and copy. So as I was telling you in my previous video that so if you want to study, so main base of geometry, actually Euclid is called the father of geometry. I think Archimedes is called the father of mathematics. So if you want to see detail of this very interesting study, I told you, you just see Euclid's element, then a lot of detail you will get. And then I told that a mathematician like Sir Isaac Newton, Copernicus, Galileo and Kepler, so they were actually scientists. See, a scientist generally studies maths also. Newton was one of the founding person for calculus, Leibniz and Newton. So those who are good in physics, what we call scientists, physicists, I called them mathematician. Yes, they were mathematician, but better term would have been scientist. So physics and maths, they go together, children, you will see. Physics has enriched maths and maths has enriched physics. So we have a very interesting study in geometry which was Main base was given by Euclid, about whom I have talked in my previous two videos. So if you want to learn about more about Euclid's book and Euclid, you just type Euclid's element in the Wikipedia and lot of things you will get. So children, we come to the end of part 5 of the video. So kindly practice question up to at least 20. Last few questions are little difficult, so that you do little later. So all the solved example, many good solved examples are there in M.L.AGGARWAL'S book. So do the solved example and do at least up to question number 20. And please do practice, and thank you children for watching this video session.